Hey everyone, today we're going to talk about L'Hopital's rule. And to get started, I'd ask you to look at the first example on the handout that you have, and you'll see that you're asked to find the limit as x approaches 2 for x squared plus x minus 6 over x squared minus 4. So we're going to try direct substitution, just plugging in the 2. And in the numerator we get 0, and in the denominator we get 0. We actually have a term for an answer like this. It's known as an indeterminate form. An indeterminate form. Now, when you get a limit like this, L'Hopital's rule states that what you can do is go back to the function again, back to the limit as x approaches 2, but instead of plugging 2 into the function, you're going to take the derivative of the numerator and the derivative of the denominator and try again. Try plugging in 2. And you'll see that when we do that, we get the answer of 5/4. So L'Hopital's rule is actually just a way that you can calculate a limit that gives you an indeterminate form. So let's just take a look right above that at the statement of L'Hopital's rule. So basically what we see here is that if the limit of a function f is 0 and the limit of the function g is 0, okay, there's our indeterminate form, and the limit of the derivative of f over the derivative of g is some number L, then the original limit is equal to L. All right, so if you use direct substitution and get 0 over 0, then L'Hopital's rule states that you can take the derivative of the numerator and denominator and try again. Try plugging in the value, in this case the value of c. And if you get an answer, then that becomes the value of the original limit. So in the example that we looked at, we were trying to find the limit as x approaches 2 for this function, and that limit is actually the same as the limit of the derivative of the numerator and the derivative of the denominator. Okay, let's take another example. In this case, we have the limit as x approaches infinity, and if you were to plug in very large values for x in the numerator, you'd get infinity, and the same thing in the denominator. So infinity over infinity is actually another indeterminate form. Now, we're going to apply L'Hopital's rule again. We're going to take the derivative of the numerator and the derivative of the denominator, and we're going to try plugging in a very large value for x again. Oh, but wait a minute. We get infinity over infinity. Well, let's see what happens if we try taking the derivative again. We're just going to get 2 over 6. And the limit as x approaches infinity of 2 over 6 is 2 over 6, which is also 1/3. So again, just to look at this example, we had the limit as x approaches infinity for this function. It gave us an indeterminate form. We tried to take the limit of the derivative of the numerator and the derivative of the denominator. It gave us another indeterminate form. So we tried again, and we took the limit of the derivative of the numerator, the derivative of the denominator, and we got 1/3. So now let's just take a look at the top of the page at the statement of the theorem. You'll also notice that if the limit in the numerator is infinity and the denominator is infinity, L'Hopital's rule also applies. You take the derivative of the numerator and the derivative of the denominator, and if you get a number L, then that becomes the value of your original limit. Now, in this example that we just looked at, we actually had to take the derivative twice. And there are examples where you may need to take the derivative multiple times. Okay, let's take a look at example number 3. I'm just going to draw a quick sketch of the graph of ln x. All right, so here is a quick sketch of the graph of ln x. So in looking at this graph, and I'll also sketch the graph of x to the 99th because I realize that may not be a graph that you're familiar with. So x to the 99th power basically has this shape. Now, what's important for us is what's going on at infinity. So at infinity, you'll see for both of these graphs, the values keep increasing. So when we go over here and look at the limit, ln x is going to approach infinity, and so is x to the 99th. There's our indeterminate form. So we can apply L'Hopital's rule. We take the derivative of the numerator. Derivative of ln x is 1 over x. We take the derivative of x to the 99th. Okay, and we can actually simplify this expression. In this case, when you're dividing by 99x to the 98th, it's really like multiplying by 1 over (99x to the 98th). And we're going to multiply that by the x that's there. We have 1 over 99, 1 over 99x to the 99th. And again, just to explain quickly how we got that. Okay, and again, just to explain quickly how we got that. 1 over x divided by 99x to the 98th is the same as 1 over x times 1 over 99x to the 98th. And then when you multiply these two values for x, this is x to the first. This is going to become 1 over 99x to the 99th. So going back to that previous screen, we know that when we're trying to find a limit as x approaches infinity and the numerator is 1, but the denominator is a really large number, like 99x to the 99th, 1 over a really large number is going to be a really small value. So this is going to equal 0. Again, we know when the value of the denominator exceeds the value of the numerator, the limit is 0. Okay, let's take a look at the next example. The next example we have e to the x over x squared. Again, as x approaches infinity, we know that the graph of e to the x, I'll just draw that here, the graph of e to the x at infinity is infinity. So this limit here is going to be infinity. We know x squared is also infinite. There's our indeterminate form. So we'll take the derivative. The derivative of e to the x is e to the x. The derivative of x squared is 2x. And we try again. E to the x, of course, is going to be infinity. 2 times x is just a line that looks like this. So again, that's going to be infinity. So we'll take the derivative one more time. And by the way, you can take the derivative in a limited number of times, because in this next iteration of the derivative, we see we get e to the x over 2. So that's going to be infinity over 2, and that limit is just infinity. Okay, and we have one more example. It's the limit as x approaches 0. So we're going to try direct substitution here, and we get 0 to the 6th, 0 squared, 0 to the 5th, 3 times 0 squared, basically 0 over 0. There's our indeterminate form again. So we're going to take the derivative. In the numerator, we get 12x to the 5th plus 12x. And in the denominator, 20x to the 4th plus 6x. We try plugging in again. Indeterminate form. And L'Hopital's rule guarantees that we can try again to take the derivative. So we get 60x to the 4th plus 12. And then 80x to the 3rd plus 6. When we plug in now, we get 0 plus 12 over 0 plus 6, which is 2. Okay, great, guys. We're going to be doing some more practice with this tomorrow in class. Have a great night.